Validation 1 is a new process in Automotive SPICE 4.0. In my trainings and assessments, I recognize it's often misunderstood. I created this video to give you a clear and practical understanding of Validation 1 so that you can discuss it with your customer, your project team, or an Automotive SPICE assessor and know exactly when and how this process should be applied. We will cover what Validation 1 means in practice, why it was added in Automotive SPICE 4.0, the essential inputs, outputs and work products of the process, and finally, who is responsible for what. I am confident this video can give you a clear overview of Validation 1. I am Giuseppe, I am a principal assessor and instructor in Automotive SPICE. I am producing several videos about Automotive SPICE and software engineering, and this takes a lot of effort. So, if you like my videos, subscribe to the channel, it helps me a lot. Thanks, and now let's dive in. Let's start and understand what this process is about and the key concepts behind it. The purpose, the goal of Validation 1 is to provide evidence that the end product that allows direct end-user interaction satisfies the intended use expectations in its operational target environment. In other words, Validation 1 exists to prove that the product works for the people and the conditions it was designed for. Not just that it meets its technical specifications, that's verification, but that it does what it's supposed to do in the real world. It's about quality in use, in the language of software quality standards ISO 25010 and ISO 25019. If you want to know more about these standards, check out my video in the link below. So to fully understand the purpose of the process, we need to understand four essential concepts: the end product, the end user, the intended use expectations, and the target operating environment. Let's look at each of them. The end product depends on what you are working at. If your organization develops an ECU, let's say an airbag control unit, this is your end product. If you are developing an engine control system, the system is your end product. For a car maker, of course, the end product is the vehicle itself. Now, who are the end users? According to ISO 25010 standard for software quality, there are three main categories: primary users, secondary users, and indirect users. Primary users, these are users who directly interact with the system to achieve their main goals, like, for example, the driver. Secondary users, these are people who support or maintain the system, such as workshop technicians or diagnostic engineers. Indirect users are users who don't interact with the system directly, but that are affected by its behavior, like, for example, auditors ensuring compliance with safety, cybersecurity, or homologation rules. Remember, Validation 1 focuses on end users with direct interaction with the product. So, if you are dealing with a sensor, like a pressure sensor or a temperature sensor, that users never touch or see, that's out of scope for Validation 1. The next concept is intended use expectations, and this is where quality news from ISO 25019 becomes relevant. This standard defines how well a system meets users' needs through software quality characteristics like beneficialness. Does it provide a valuable benefit to the users? Freedom from risks? Is it safe and secure? And acceptability? Is it trustworthy? And does it comply with relevant rules and requirements? So Validation 1 is about testing the product against these real-world expectations from the user's perspective. Finally, we have the target operating environment. This is the real world where the product is meant to function. For an ECU that interacts directly with the driver, for example an infotainment system, the vehicle itself is the operating environment. But validation should also consider the actual operating conditions, such as weather or road types, traffic conditions, and other environmental and human factors that may influence how the product behaves in reality. In other words, validation happens where and how the product will really be used. Let's go now to the second point. Why was Validation 1 introduced in Automotive SPICE 4.0? There are three different reasons. First one is to close the gap of Automotive SPICE 3.1. Automotive SPICE 3.1 focused heavily on verification, checking that the system and the software outputs meet their specifications. However, verification doesn't prove that the final product actually meets the customer's or user's needs in the target environment. Another big reason why Validation 1 was introduced in Automotive SPICE 4.0 is the alignment with international standards, especially ISO 26262 for functional safety and ISO 21434 for cybersecurity. Both of these standards require validation of safety and cybersecurity goals, not just at the component or ECU level, but at the vehicle level, where everything comes together. For example, in functional safety, ISO 26262, the safety validation of the integrated system that is usually tested at vehicle level aims to provide evidence that the system is appropriate for its intended use and that the implemented safety measures are effective. In cybersecurity, ISO 21434, validation activities can include performing penetration testing to verify the effectiveness of cybersecurity measures, and reviewing whether all identified cyber risks have been properly managed and mitigated. Another key reason why Validation 1 was introduced in Automotive SPICE 4.0 is to ensure consistency with homologation and type approval frameworks, the legal process required to put a vehicle on the road. Homologation is the official approval granted by regulatory authorities that a vehicle meets all applicable safety, environmental, and cybersecurity regulations. Without homologation, a car maker simply cannot sell or register the vehicle in a given market. Traditionally, homologation focused on mechanical and safety performance, for example, braking distance, lighting, or emissions. But as vehicles have become software-driven, regulators have introduced new rules that also cover software, cybersecurity, and update management. Two major frameworks are the European regulations UNICE 155 and 156. The first addresses vehicle cybersecurity and cybersecurity management, and the second, software update management systems. Both of them require validation evidence showing that the system and finally the vehicle performs safely and securely in its intended operational context. For example, under R155, cybersecurity validation may include demonstrating that all relevant attack paths was considered and that the implemented cybersecurity measures are effective in real driving conditions. Under R156, validation includes confirming that the software update process works reliably, securely, and safely once deployed on the actual vehicle fleet. So by introducing Validation 1, Automotive SPICE 4.0 is aligned with safety, cybersecurity, and homologation norms. Now let's move on to something very practical, the key inputs and outputs of the validation process. The inputs provide the foundation for validation planning and execution. In Validation 1, the main inputs typically include the stakeholder requirements. These come from the SYS1 process and describe what stakeholders, drivers, users, customers, and authorities expect the end product to do. They define what the intended use actually means. Then we have the validation strategy or validation plan. This document defines how validation will be conducted, who is responsible, what environment will be used, and what success criteria apply. This is your roadmap for validation. Then we have the operational scenarios. These describe how, where, and under what conditions the end product is expected to operate. For example, typical driving environments, user interactions, or regulatory contexts. Then we have the test environment. This is the setup in which validation will take place. This could be a real vehicle, a prototype, or a test bench. Then we have acceptance criteria or quality in use metrics. These are measurable conditions that define when the product can be considered valid. This can come from the ISO 25019 quality characteristics, customer specification, or regulatory requirements. Of course, operational scenarios, test environment, and acceptance criteria can be part of the same document. Once validation is performed, the process produces several key outputs. First of all, validation results and records. This contained detailed evidence of each validation activity, including test results, evaluations, and observations. This is the core proof that the validation took place and that the product was tested in the target environment. Then we have validation report, a summarized document that evaluates the results against the acceptance criteria. This document should clearly state whether the product fulfills its intended use or not, and list any open issues or deviations. Then we have confirmed evidence or compliance or non-compliance. Depending on the outcome of the validation, you'll have either an acceptance confirmation, for example, a customer sign-off, or action items for further improvement. We have also updated validation environment and process data. This is the feedback and lessons learned for future validation activities. This ensures the continuous improvement of the validation process. Finally, we have traceability links. This is the bidirectional traceability between stakeholder requirements, verification measures, and verification results. This is often also checked by assessors and auditors. Now let's talk about who is responsible for validation activities. This is one of the most important and sometimes most confusing parts of Validation 1. So let's make this clear. Validation is a shared responsibility. It's not the job of a single person or a single team. It's a shared responsibility across different roles in the projects, each with a different focus. In general, three main groups play a part in Validation 1. These are the car maker, the supplier, and the approving authority. The car maker is responsible for defining what needs to be validated, meaning the intended use, the target environment, and acceptance criteria. The car maker ensures that the validation is done according to stakeholders' expectations and regulatory requirements. Then we have the product supplier. He is responsible for planning and performing the validation activities according to the defined strategy. He is also responsible for executing the tests, collecting the results, and producing the validation report. Finally, we have the approving authority. He is responsible for reviewing and approving the validation evidence. This could be the car maker himself or an external authority, like in case of type approval. His role is to confirm that validation results are sufficient and credible for acceptance. Now, it's very important to clearly agree and document who does what. Typically, a RISI matrix is used. RISI stands for responsible, accountable, consulted, informed. For example, responsible. This is the engineering team executing validation activities. Accountable. The project manager or the system owner ensuring validation coverage and quality. Consulted. These are safety, cybersecurity, and regulatory experts. Informed. Customer, assessors, or certification body. These agreements must be formalized, ideally in project documentation or contracts. Finally, you have to make sure that the responsibilities are reflected in your validation plan, work products, and review records. This ensures transparency and avoids conflicts later during assessments or audits. In short, the car maker defines validation goals and acceptance criteria, the supplier plans and executes validation, the approval authority reviews and approves the results. Okay, let's quick summarize what we have learned about Validation 1 in Automotive SPICE 4.0. The purpose of Validation 1 is to ensure that the end product truly satisfies the intended use expectations of the end user in the real operational environment. The purpose aligns Automotive SPICE with ISO 26262 for functional safety and ISO 21434 for cybersecurity, both of which demand validation at vehicle level, and of course with homologation. We have checked inputs and outputs of the process. Validation starts with clear inputs like stakeholder requirements, validation plan, and operational scenarios, and produces solid outputs like validation results, reports, and traceability evidence. Finally, we have checked the responsibilities. Validation is a shared effort. OEMs define the goals, suppliers perform the activities, and customers and authorities review the results. Clear documentation and agreed roles are essential for transparency and compliance. If this video helped you understand Validation 1, give it a like and share it with your colleagues. Subscribe to my channel to learn more about Automotive SPICE. I'll see you in the next video. Thanks a lot and arrivederci.